All right, LeetCode 15, 3-sum. Let's take a look at the question. So given an integer array numbers, return all the triplets. So we can have number 1 plus number 2 plus number 3. So, and you can see such that I doesn't equals to j, I doesn't equal to k, and j doesn't equal to, so basically means 3 different numbers, right? And then all 3 of them added together equals to 0. And notice that the solution set must not contain duplicated triplets. So this is also very important, is we don't have any duplicate. So we have to do something if we find duplicates. And here's the example, and then 2 outputs, right? And return an empty array if there is no result. Okay, so how do we solve this one? I think a straightforward thinking will be, because we need to find the three, right? Three numbers in the array and add them up together. So we were using a for loop, and then we will use the for loop to pick up the first number, and then probably we're using another for loop to find the second one, another for loop to find the third number, and we add them together. And if they are zeros, then we will check if the result is duplicated. So yeah, definitely we can solve this problem by doing that using the brute force. However, the time complexity using that method will be O3, right? So I think another better way to do this is when we have an array, right? Numbers is this called a two-sum, this problem. We have a similar problem called two-sum, right? But so for that two-sum question, we will have a target, right? Number to check if two of these items will add together equals this target. So this sounds already we reduced the one level of calculation, right? So we very likely we are calculating the time we're using will be from O and 3 to O and square. So that's why that's what we're thinking right now is can we use the two-sum method? We already know how to implement it to solve this problem. Okay, so for two-sum we have a target number, and for this one we need to find something AI plus AJ plus AK equals to 0, right? By simply calculation is we can change this method to be something like this, equals minus AK, right? This will be our two-sum, and this will be our target, right? So what we are trying to do is we will just fix one item, right? And check if the other, if two, so if, for example, if this is a K, if we fix this AK, and then we will go through the rest of the array to find if we can find AI plus AJ equals minus AK, right? And then we moved AK to the next. Oops. Sorry. we move the 8k to the next, and then we will search just the rest of them. All right, think about it. Take a moment to think about it. So our case here, we already went through to check if the rest of the array have two items add together equals minus AK, right? So now if we move the K to the second one, do we need to check this one again? I would say no. The reason is, so from the last iteration, right, we already checked this box. So we're fixing this box. For example, we find two of them here, right? Yeah, let's do this to make it even. Let's do this. We already found this two. So this 1, 2 plus equals this minus this. So three of them add together, right, equals 0. So when we move the k to the next pointer, to this part, this is 1. If we will reconsider this 0 position, you will have the same, right, result one more time. That's why we can exclude this one this time, and we only need to check the rest of the arrays. If we can have anyone, we can find a new set of numbers equals to 0. So this this is basically what we are thinking right now. Okay, another scenario is, because the question talking about see, notice that the solution set must not contain duplicate triplets. What we're thinking of the duplicate triplets is if let's go back. Let's also think what about let's redraw this picture maybe. For a given array, right? But this, right? Let's do this. 10, 9. Okay, something like that. 8. So when we fixing the k at the first time at k equal to 0, then ak plus a0 plus a1 plus a2 equals 0. We got one set. And the next time when we move the k to here, do we need to calculate it again? So think about it. Do we need to recalculate everything again? I would say probably not, right? Think about it. The first time, right, you calculate this already, and you get the number this plus this plus this equals to 0, right? And by doing so, you actually already iterated the whole set. You find the first three, and then like together equals 0, and you didn't find any other two, right? Adding up this one equals to 0. Now, because the value of this one and this one is equal. This time you iterate the rest of them, but because the first item is equal to the value, you won't find another set in the rest of the array either, because if you can find one, let's just see, if you can find one here, plus this equals to 0, then you should already find that set when you calculated this one, right? You should have another set, that's something like this plus this also should be equals to 0, but you didn't find it, which means you won't even find it this time either. That's why when you find the two values are equal together, you can skip this turn, and just move it to the next pointer. All right, so that's basically what we're thinking about how to solve this program. So we will try to implement it. So let's see. Another thing for using two-sum is we know that array has to be sorted, right? So the first thing what we're going to do is let's do first of all, let's do some edge cases, right? If not nums, right? Or I will see none of nums is less than 3, I will just return empty array because no result for sure. Now what we can do, the first one is we will just sort the array. Okay. After this, we will do just iterate it. We will fix one. So for let's say I in range of nums, right? We will do like this, right? We will check if these two values is equal together, and then we will just skip one loop, right? We will continue to do it, but we need to do the first one, right, instead of second one. So we will compare is AI and a I minus 1, right? We only do this check when we come to the second position. We will check if this AI A2 equals to A1, right? So because otherwise, if you skip the first one, you directly start the second one, you will miss the 1, 2, and 3, these three numbers. Okay, so what we will do is then we will see if I is above 0, so not from the first one, and if I would say nonce I equals nonce I minus 1, right? Then we continue. Otherwise, we will call, let's just make it, we will just call the two-sum function. All right, so we will define the two-sum function here. So we will just do two-sum. Let's do two-sum. Okay. So what we will need for the two-sum function? We will need the numbers, sure. We get a target. Then we need to have a start and end point, right? So start and end. What else we need? Oh, we need to return the result. So we will have the result. let's define a result to be start with an empty array. So then this will be a classic two-sum question. We will using two pointers and start from the beginning and the end, and we will see if we can find two sums, right, equals to the target. So we will just see, we'll start from the left, right, equals to start and end. And well, left, less than right. We'll check if nums left, right, plus nums right. We'll compare with the target. If it is larger than the target, if it's larger than the target, then what means is currently is too big, so we will reduce the right one to move the pointer to the left. Else, if nums left plus nums right is less than target, so we move up the left pointer, right? Else, now this time we will have the nums left plus nums right equals the target. Okay, so but do we write it to the result? That's depend, right? Because this time it said because the question asks us to not contain the duplicate triplets, so we need to check if the result is duplicate. How do we do that? We know we can compare it with the last pair, right? Last pair equals to, we will store two numbers, so we're using the tuple to do this. I will see if nums, do this, if nums left and nums right is equal to last pair, we will just continue here. We won't you won't do anything, right? Because else, so let me see. So no, we will see if this is a new set, right? Doesn't equals to read it. So what we will do is we will append new array. This array will be minus target, right? And nums left and nums right. What if they're equals to last pair? Then we won't do anything, right? We don't have to write it into our answers. But however, we still need to move our pointers. So we still do right minus 1 and left minus 1. Sorry, plus 1. I think that's right. Okay, so let's go back to our main function. Here we need to call our two-sum. Okay, we pass in the nums. Nums is nums, and we type in our target. What our target will be here. Here we put we were fixing one nums I, right? So what we're going to do, the target A will be negative nums I, right? So the start point is when we fixing one, we will move it to the next one, right? So we will start from I plus 1. The end will be the length of nums minus 1, and then the result will be the result. Okay, so after the for loop, we will just return the result. I think that's it. Let's check our code. Oh, it's accepted already. Submit. Answers. Let me see. Oh, we have a duplicate. Oh, I forgot one thing is here, right? We check if it is equals to last pair. If it doesn't equals to last pair, or no wonder is yes or no, we need to update our last pair, right? Because our new pair right now equals to nums left and nums right. So next time if we see it again, we won't, store the duplicate one as this. All right, let's run again. All right, this time accepted. All right, that's it. 3 sum.